order of stars and words are the orders I take from you, away from language rumblings. I cannot say, not I, forbidden little dogs, and knowing if stars have anything to say, we cannot hear by charting days or telescoping lens of one flash through another. Microlensing, as Dimitri reminds us, reveals millions of years. What happened were never arrived until seen. The astronomer's eye is never naked, never taken in by moving stories of night. Word order is syntax, synapse, transfer of energy, light of fuse, obfuscating, minute to decide how to say what constitutes self and world and you. There where nothing stays until nothing stays still. The mountain points to a star's order, standing over peaks and words. If throne fall to lack of sky, alphabets split themselves to make diction. Other airy sprites descend to hand us speech. Allow I to tell you from all the others, all the wonder lost in each instance of order, lost in disorder too. No words from Etudes D&D C. Alexander. This was a poem by Charles Alexander, and you can see the link there. eoagh.com/no matter where. In fact, that's a little article that that goes into some more detail of this person's poetry and some other thoughts of his. But I'm not here to talk about poetry. First of all, what are you listening to? This really
That's what I wanted to know.
And the background voice is also wondering that as well. Well, wait, hold on a second. Let's focus on me first of all. So this
is all about you.
Oh my gosh. All right, the background voice says this is all about me. All right. This is SG2 on Space, the only weekly space show. So you can see us on www.facebook.com/theshen show. And guess what? Now we are also on YouTube. So for this particular episode, you can go to youtube.com/watch V = V. You know what? I'll just type it out here later. But point is, you can go on YouTube and also find SG2 on Space. This current episode is episode, well, actually, you know what? Before I even go further, let's see here. What do I normally do? I say, all right, there's somebody else, the hidden voice. Who is that? There.
How you doing, Shan?
Good. I think, what is it? Better than I deserve, or whatever you say? I don't know. What do people say?
You're doing better than you deserve.
There you go. So this is Dr. Leonard Kramer. For those of us who have been watching the show, or
excuse me, I'm missing my swag. Hold on.
Oh yeah, what's going on there?
Oh. There, that's better.
Okay, so Dr. Leonard Kramer here, and yeah, I mean, you look good. I like your clouds, your shirt.
Oh, yeah. This little thing.
Yeah, I don't think I've seen it before. So indeed, and so in any case, now that Dr. Leonard Kramer has the swag on, before we go on, I do have to say for everybody support the show, patreon.com/SG2 on Space. This is actually, like I said, the first time I've done this in a while on YouTube. So, if you're ideally same format as before. Also, thank you for still our supporters and patrons, Kyle Baker, Sam Welsh, and Atumra, the last of which was my producer for 2 years. So thanks. Lord Rod. I actually should. I wonder if he still watches the show, but that's besides the point. So maybe not. I don't know. But I wanted to talk about something called, so episode 169, Microlensing today. So that poem, that very abstract poem, I got to say, I read, for anybody who heard what I said, you probably had no idea what, that poem did not help illuminate what microlensing is at all.
I agree.
Which is fine, because it was written from a poet's perspective, which, that's what happens sometimes. You just like to, throw words in there. But since we are talking about it, science, previously, a number of occasions, Leonard, Dr. Kramer here, has talked about gravitational lensing. I would say microlensing is essentially the same phenomenon, except on a smaller scale. So, first of all, Leonard, can you refresh our not reader, our viewer, what,
Our viewers, our audience, our
yeah,
esteemed audience.
our esteemed audience, what is gravitational lensing? If you can review that for us.
Okay, so let's see. Einstein uh, sort of redefined physics with the notion that there's something called space-time, and that gravitation, that mass and gravitation is a curvature of that effect. And so it's well verified that light, when it passes close to a massive body, like for example the sun, it bends. And this has been um, abundantly verified by observations, by the Hubble Space Telescope, by now uh, the other telescope, the help me out, the
James Webb.
James Webb. It hasn't been around long enough for me to get used to thinking about it, but the James Webb Space Telescope, and so we often see these some distorted images of objects that happen to be aligned. So if a galaxy, if one galaxy is in front of another galaxy, the light from the more distant one that's aligned with our location will appear to be bent, and it manifests as a kind of an arc or a ring around the the object that's gravitating, or that's bending the space around the object. And so there's actually some very exciting studies now to possibly exploit this using the sun, and having the sun act as a gravitating mass, and a telescope, a space telescope that's located at somewhere between 500 and 600 astronomical units. Astronomical unit is the distance that the Earth is from the sun, and it's a convenient kind of yardstick that we use um, to measure distances and so forth. The solar system is on the order of 40 or 50 astronomical units. The radius of the most distant planets, and uh, um, humans have sent out several probes that have gone beyond there, including the Voyager and the Pioneer uh, probes that were sent out in the 1970s. These have gone, these have been in space for 40 years, and have uh, um, not gotten that far yet. But there are proposals now to
Right.
send maybe like something like a swarm of satellites,
Mhm.
small satellites, to a distance of 40 between 500 and 600 astronomical units, not light years, astronomical units. And so what they will do is they will look back at the sun, and they will position themselves between the sun, between a distant object that we want to observe, and the parallel beams of light that are coming from that object will be bent around the sun in an arc and make a circle. And we can exploit that because it's an enormously magnified image, although
Mhm.
it's greatly distorted, and it's not even really focused to a point. Things, light rays that are passing further away from the sun would get bent less than those that are closer in. These are good examples of this
I mean,
effect that we're
you can
talking
see how
about.
it's like distorted, but it definitely increases the amount of light that
It
reaches
Yes,
us.
and so here's the thing. It's estimated that with technology that we have now, we if we can achieve this goal of getting a satellite, or a string of satellites, like a swarm of satellites, and maybe we'll explain that in a bit. That the magnification that would be affected by this this proposal, it would be 100 billion times magnification. In other words, it's effectively using the
Did,
an
did, did you just say 100 billion times?
100 billion times the size of the object. And so
Wow. Okay.
and it literally would allow us to image, um, if we can figure this out, it would allow us to image the disks of planets around distant stars that are up to 100 light years away. We would be able to image the disks of the planets, and maybe perhaps resolve whether there are continents on there. I did see a
Mhm.
lecture by someone who said that it's thought that the pixel size, the minimum resolution, would be 25 kilometers. So if you can imagine seeing something that is 100 light years away to a resolution of 25 kilometers. So it would be like you would be able to see the lakes and the streams and the oceans and whatever else in the clouds and whatever else that would be on these planets. Now the technical challenges are pretty significant for doing this, but this is a real thing. This is a thing that actually could happen. It will take 30 years to get a swarm of satellites out there with
Right.
the technology, and what will happen is they will go out there and they will sort of align themselves like strings on a like pearls on a string, and also kind of in a swarm around there, and they'll use the distant objects, the distant solar system's central star, as kind of a
Mhm.
guide, and then other satellites, and there'd be small satellites like maybe the size of a laptop, satellites of that nature, and thousands of them, and they would be out there, and they would be all communicating with each other, all networking together, and working toward resolving the image of that solar system. And so it's not a sci-fi. Well, it is. It's
It,
it's
it,
not real now, but it's well within our capability to be able to do this. I mean,
right.
I don't think that there's any significant technological um, impediments in this part of the 20 in this early quarter of the
I
21st
think
century to be able to do this thing.
yeah, I mean, I'm just I want to okay, this is really interesting, which is why, you can continue talking about it, but
So,
I
okay.
wanted to, oh, sorry, go ahead.
No, you go ahead. Where are you? How come where
How come you
where
only see
where are
yourself?
you, Shen? Yeah, I only see myself. I feel lonely. Okay,
Okay,
there we
well,
are.
okay, I wanted to okay, before we go on talk about microlensing. So this is kind of, I don't know why this image is horribly pixelated, but anyways, this is what you're talking about, right? Partly using
I'm
the
not
sun.
sure. I think so. I don't really recognize what the
Yeah, I mean, this is just like a graphic showing, hey, you use the
okay.
sun as basically a telescope to you can possibly image exo Earth or exoplanets up
Yeah,
to 30 parsecs.
and what the satellites would observe would not be an actual image of the distant object, of the distant solar system. It would see like the ring, the
Mhm.
distorted image that's around the star, and then as you move around, you would see different parts of the you would
Right.
the light from the star would be distributed around the sun, and then we would use computers. We'd use a computer program to deconvolute that image to to discern an image, probably of about the same resolution as we're seeing of the Earth there,
Yeah, exactly.
and that would be very very. It's a very very compelling thing, and um,
So
I don't know how much budget, how much it would cost. But and it would take the better part of half a century, to really get all of this done. The signals from a 500 light from 500 AU astronomical units, 5 to 600 astronomical units, would take something like a week to arrive. So
right.
right now it takes a second and a half to get us to hear a signal from the moon, and then it's something like 15 to 20 minutes to Mars and and Venus, and longer periods, 30 minutes to the outer solar system. But for an object this far away, it's outside of the Kuiper belt, and really it's in the interstellar space. But
We,
um,
I
it
was. Mhm.
it is within our capability to do this. Oh yeah, this is a good
Yeah.
illustration of the kind
Well,
of effect that I'm talking about.
well, this is I was gonna say you talking about stuff in the future. Now we could actually use effect called microlensing, where essentially using it's the same physics where
Hmm.
a gravitational body bends light, except this time the gravitational body that bends light actually an exoplanet,
That's the
and we
actual
can
thing that we're trying to
actual
observe.
thing
Yeah.
exactly.
Hmm.
And this actually has been used to detect exoplanets, which is amazing.
Yeah, I have to tell you, I didn't know that until you introduced me to this. So I didn't even know about this. I knew that this was possible, but
Well,
you
I
know,
mean, we know about like I find it interesting that when we talk about when I think about exoplanet going around a star, I think about what do you call it, like the transit effect, right? Like it passes in front of it,
uh-huh.
and the light curve
Yeah.
like drops. But this effect actually has the opposite, where the light curve actually increases because briefly, you have it actually with this planet in front, it actually causes the light rays to go like this, so it actually
Yeah.
magnifies the star's light curve. So,
Right.
um, but
So you had some data to show. I think you were showing me a paper earlier.
right. First of all, this is just letting you know, this is called gravitational microlensing. So you have here Earth and a closed star and a brighter, more distant star. So this actually, so this could be, really, yeah. So like using this effect, you can see how on the top graph, it basically has just the closer star is basically is distorting the light curves, not the light curves, it's distorting the light rays from the distant star. And in
And it
the
makes
second
it brighter.
example,
Makes it look brighter.
exactly. The
Uh-huh.
bottom example shows something which I was saying about how this closer star also has a planet, which adds a little blip when it crosses in front of it. So that also that enhances it even more. So, so
So the only downside to this is that it's very rare that we'll find one object that's directly in front of another object. So so there's a little bit of a, a disadvantage there. So
that is true.
hmm.
Although, so this is actual. This is from, I think this was using the Hubble Space Telescope, and so I mean this is obviously a graphic representation, but they've used
Uh-huh.
this to detect exoplanets before. So exactly what I was saying, right? Like what the previous depiction showed. So when a foreground star, the red one, say passes in front of a background star, it brightens the light of the background star. And then if a planet is orbiting the foreground star, it too will gravitationally lens the background star
Uh-huh.
for a shorter
Hmm.
duration. So from this, you can actually figure out, what the size of the planet is and its orbital period. So, which is
So
pretty.
in those papers, did they say how far away these objects are? These are kind of like rogue planets that are not associated with
This
any.
this example is actually not a rogue planet because it is orbiting a star, but I am getting to that.
Oh,
So there is this telescope out in. So aside from detecting exoplanets that's orbiting around other star systems, you could also use this technique to detect what's known as rogue planets. And rogue planets are essentially planets that does not have a parent star. Um, so, in other words, it's just kind of free floating there on its own.
yeah, we wouldn't have any other way of detecting such an object,
Yeah, like it's
you know?
completely dim, right? So
Mhm,
how would you detect it? I mean,
mhm.
that's just very difficult. So it's just giving you. It's also scientifically, I guess, it's also termed a FFP or free floating planet. So it's not gravitationally bound to any star or brown dwarf. And they, unfortunately, I mean, they are formed from planetary systems, but they're later ejected. So now, how does this relate to this microlensing? Well, it turns out that you can use this technique to actually identify these rogue planets. And this is a paper that recently came out, which explains how you like. So these are light curves,
Uh-huh.
which Leonard, can you explain to our audience what light curves are?
Well, this is just the image of the this is just the intensity of the light from the star.
Right.
So as a
So
function of time, right?
yeah.
Mhm.
Okay. That's okay. I'm trying to let me see here. So this I'm going to point out this paper here, which is called Terrestrial and Neptune Mass-Free Floating Planet Candidates from the MOA to 9-Year Galactic Bulge Survey, which was a collaboration between New Zealand and NASA and some Japanese universities.
And all those
Um,
guys.
and everybody else here.
Uh-huh.
Okay. Apparently, it's truly an international effort, as you can see. America, Japan, Italy, Poland, New Zealand, Spain, France. Okay, so basically, they used that particular telescope based in New Zealand and observed. Took like 9 years of observation data, and they found 6,111 microlensing candidates and identified statistical sample consisting of 3,535 high quality single lens events with Einstein radius crossing times in the range of blah blah blah. Okay, so what does all this mean? I mean, let's go to the. I mean, there's some math here naturally. I mean, you have to have that, right? But if I can scroll down all the way to where the actual data is, or rather, yeah. So like a graph like this. So what do we see here? You have these. Well, you have these light curves, and there are these occasional, like you can see there's like a spike
Right.
here, and you magnify that. All right, and basically saying zoom into that time frame, right,
Mhm.
between 4600 to 4602. And then from this they can actually figure out like, oh, okay, so increase the magnification this much for this amount of time, and they can figure out the some details of the rogue planet.
Yeah, so the brown or red curve there is actually a model of some kind of distribution that they expect, and the black dots and is the actual data that they recorded, and so they record for a very long time, and they see spikes. This is how I'm interpreting this. They see some spikes, and so then in the lower panel they expanded the spike. Is that what's going on there? Is that how you understand that?
That yeah, I mean that's how I understand
Right.
it.
Um, and so this is evidence of some object that's passing in front of the star over a period of hours or days.
Yeah, I'm not sure what time units this is. So I mean, this is definitely a massive amounts of data. So the clear short single instantaneous magnification can be seen in the 9-year constant baseline. Major source of false positives. Okay, flare stars and dwarf. Okay, so they definitely have to remove a lot of the noise, I suppose.
Uh-huh.
Confirm there are no other transient events. So there's no periodic variability in the let me see, light curves of indicating that these are not spotted flares. So they remove they remove the data that is from sudden flaring stars. So in any case, and then they look.
I get it. It's really interesting.
Yep.
So, and this is um
The theta E using the MCMC method for 12 short scale time events with the best fit indicated relative motion values of blah blah blah, which most events would consider reside the structure of. I mean, you're gonna have to read the article to actually naturally
yeah.
understand more details on this. definitely for those who are
But
interested.
the bottom line here is that those curves that we saw earlier are evidence of a object that is passing in front of a distant star, and it's making the star appear brighter because of the gravitational lensing from an object that's from a dark object that's passing a dark isolated object that's passing in front of another star, and that occurs over days to
So yeah,
hours, something like that.
I think it's to tie it down, to tie it back to fundamental physics. This whole event, this whole thing, whether what Leonard described earlier, using galaxies or the sun to magnify stuff, or in this case, using planets to magnify what's it, it's all based on this gravitational lensing, which is one of the predictions of Einstein's general theory of relativity, um, which is that what I guess in this case is that gravity bends space time. And
Gravity bends space-time. It was first observed, I think, in 1917 or 1918 by oh, I can't remember, but it was a prediction that was made about an eclipse.
yeah,
Einstein, I think, he wanted to know if you could. I think he asked some astronomer, can you see the stars next to the sun? And of course, you can't see stars that are adjacent to the sun when the sun is, out. But in a eclipse situation, you were able to see that. And so they did go on an expedition, and I've forgotten the details. I thought maybe it was to South America, and they did in fact photograph an eclipse, and
that's
this
actually a really interesting history.
and
That
the stars that were the star there it is, Arthur Eddington, yes. And I was almost said Eddington, but I wasn't sure, so that's why I didn't say it. But yeah, and I was off by a year. What did I say? 17, 18?
yeah, you were
So,
really
yeah,
close.
so it's 1919. I know that I know that World War One was just winding up, and um,
This is
so
actually wow, that's really neat. Like this is actually one of Eddington's photographs of 1919.
yeah, so they had cameras.
Yeah. I mean, I know they had cameras. It's just
Uh-huh.
it's I mean, it's pretty amazing that I mean they didn't have any spacecrafts or like huge observatories, and yet they were able to prove
Right.
this.
And so
Like
I don't
serendipity.
exactly know how to interpret that particular picture. I've seen it before, but um, they were able to take a picture of the eclipsed sun, and of course that picture is a negative. Uh, it's it's the 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 actual image is opposite that. The dark areas are very bright, and
Right.
the central part that looks very bright is actually the eclipse. That's the moon is in front of the sun, and so they were able to show that when the sun moved, you know, that the stars, they had catalogs of what the stars looked like, the relative. They were able to see that the stars that came out and were visible in during the eclipse. And I've witnessed that, by the way. The stars come out. Uh, and,
Are you saying you've witnessed like a
well,
visual effect of gravitational
in
lensing?
2017, I participated in, or I went to
Hmm.
Tennessee to see the total eclipse in the summer of 2017, and I made a lot of personal observations about things that
Hmm.
occurred during the eclipse. It's a very eerie and unusual.
I was actually I think I was in St. Louis, I think, or somewhere, and saw that as total eclipse as well. And
Yeah.
it was I mean I stared at the sun with wearing the eclipse glasses. That was
Well,
pretty
I
cool.
used my steampunk goggles.
Oh really?
Yeah,
Perfect. I
they
mean, what else? What
well,
else?
they have a like a number 12 welding glass.
Oh, okay. I mean, that's
so
perfect
so
usage for them.
but they are my steampunk goggles. But I want to here go back to the picture there.
Yeah.
I just wanted to put a bow around this. So what happens is when the sun is there, the stars that are around the sun become distorted. In other words, some of the stars that are behind the sun appear, are you're able to see when the sun is eclipsed, and it's because of the gravitational
So,
effect. And also
right,
Einstein did a calculation. He said it'll be bent by this much, right?
and it was shown to be
And
that
and
much.
it was a test. It was a test of a scientific theory.
Or,
It's a real.
now you have to
Yeah,
observe this during solar eclipse because otherwise, normally the sun's so bright you wouldn't even notice the star.
you can't see stars around the sun, but so
Right. The
yeah,
the light from those stars are bent by the sun, but normally without a solar
yeah.
eclipse, the sun's
Now,
light just overwhelms everything else.
Now, some people might ask, well, I mean, what about the moon? Does the moon distort it? Well, the problem, moon is so much smaller that it doesn't bend space time enough to be able to observe that. To my knowledge,
Oh, I see.
maybe some very very precise kinds of observations
Can
do
can
show
we
that.
use like the planet Jupiter as a gravitational lens?
Not so I'm not so much not so far as I know. I do know how to do the calculation to find out how much it distorts a star, and I could probably have a look at that.
How much it distorts a star is from the Einstein
Right. Okay,
radius
so this is the
derived.
picture. Yeah, this is the picture right here. So you see the eye over there on the right. That's supposed to be an observer. So that's your eye or my eye. And we're looking at and so then the dark object over to the left is say a star that's behind the sun. And ordinarily it wouldn't be visible or just maybe it's just barely visible,
Mhm.
along the edge there. But the light that's actually seen is along that line where it bends because of
Yep.
the distortion of the space-time around the.
And this one too.
And so what it looks so what it looks so what it appears to be is like the circle that's over there, the two circles to the left, all the way over to the left.
Yep.
You have the impression that it's in those locations.
That's why
And
you see two of them.
yeah, and actually there are some cases where in the cases where galaxies are distorted, you'll see an actual image of the two galaxies that are distorted. There's some pictures from Hubble and maybe from James
Well, I
Webb.
mean, there, yeah, like, uh, I can just actually, oops, go back here and
Yeah, yeah, that
this,
picture right
this
there,
even
that one right
very
there.
representative example right here. I mean,
Yeah,
look at that.
that's
Goes
all one
around.
object. That's all one object, and you can actually see
Yeah.
some structure. So it's some kind of galaxy that's behind the central galaxy,
Yes.
and that's all because the light is being bent,
Yeah.
and it's
I mean,
and
another example would be like this one, for instance. Look at that.
yeah, I haven't seen this one before, but yeah, I presume that
there's
that's the
four of
same
them
thing.
here.
Mm-hmm.
So four images of the same distant quasar appear around a foreground galaxy. So the
Uh-huh.
middle one is the one that's bending the light, and these four here are really the same
Uh-huh.
object.
Yeah, and so you
So,
could ask the question, why is it four? What is it? And I don't know the answer to that. Why is it, you know,
um,
um,
that's that.
it must have something to do with the structure of the gravitating object, you
So
know.
here it is. While gravitational lens light sources are often shaped into Einstein ring, like that first example we showed, due
Uh-huh.
to the elongated shape of the lensing galaxy and the quasar being off center, the images form a peculiar cross shape instead. So,
Okay.
so it just depends on it not being perfectly symmetrically
Mm,
aligned, and
yeah.
the distorting object itself not being perfectly symmetrical.
Okay.
So
I'll accept that. I don't understand that the way I want to.
mathematically, I guess just
Yeah.
have to write equations or something.
I don't know.
So
I don't understand that the way I want to understand. But it's okay. I don't want to.
I mean that's
It's me. It's not you.
I mean I to understand it completely, I would need to
Uh-huh.
look at the math as well. That's for
Yeah.
sure.
Looks like they have a little animation there too that
Which
looks
one?
there's a
Oh, this
is there
one's is this one?
I don't know what that.
Oh,
Oh yeah.
that one's actually kind of interesting. I
So
mean,
this is a simulation.
right.
Okay. So
But
there
it's
were
a
there
simulation based on actual real image though.
uh-huh. Yeah.
So wow, you see that? That thing was
Uh-huh.
there and then that magnified it completely. This
Right.
one, I think is what you're saying, right?
Yeah,
Light
that one
sources
is
have
that one's interesting. So there's a central object, and so the gravitating object that's moving away kind of continues to pull some of the it continues to distort the image of the galaxy or the object. Yeah.
Yeah, actually, that is kind of interesting. The
So
aqua circle is a light source as it would be seen if there were no lens, while white spots are the multiple images of the source. Okay.
yeah.
Oh, okay, I see.
Hmm.
So this, wow, okay, interesting. So yeah, I mean, there's all sorts of simulations out there with this, there's actually way more detail here than we've bothered going into. I mean, apparently
Hmm.
there's 3 different classes for strong lensing, weak lensing, um, and then so I guess what we showed up as possibly that article I described was probably weak lensing, and then oh wait, no, that would be microlensing. Sorry.
Uh-huh.
So yeah, so like the first examples of what you said using galaxies to distort, that's definitely
Yeah.
strong lensing. It's really obvious. Then there's weak lensing, and then there is the microlensing where no distortions in shape can be seen, but the amount of light received from a background object changes in time. So and I think all these depends on how
Yeah.
large the distorting object is. I
Hmm.
mean, how massive.
Yeah.
So all right. With that, shall we move on to one of my favorite topics?
Sure,
What do
that's
you
what the
think?
show is really about.
What do you think that is? What do you?
It's it's
So,
one of the X Files, I'm sure.
all right. So once again, this is. I'm not saying you need to believe anything, but hey, why not, right? Why would you not believe these things?
But
Okay.
don't pick what to believe. Let what to believe
You,
pick you.
January
okay.
in Massachusetts.
All right, let's hear the
Okay.
full story by this robot voice. Apparently, it's a famous alien abduction case.
All right.
So let's see it. And if okay, I'm just gonna play
Just
it. We'll
just
just
play
hear
it. Sure.
In Massachusetts on the night of January 25, 1967, one of the most celebrated cases of
Is that
UFO
her
abduction
husband?
began. Betty Andreesson was working in her
I
kitchen
did
while
not
her
make
7
this
children,
video, so if it
mother,
looks
and
really
father were in the
silly,
living
I mean,
room.
we can just make fun of it.
Shortly after 6:30, the lights in the house briefly blinked. Immediately thereafter, a reddish light began to beam through the kitchen window. The sudden darkness in the house set the kids' nerves on edge, and Betty ran to comfort them. Her father ran into the
All
kitchen
right,
to peer out the window and find the
Okay.
source of the unusual light.
whoever made
To
this
his utter
video
shock, he
did
saw
not
5 odd-looking beings coming toward the
make a
house with
very
a
good
hopping
video.
motion.
Odd
Before he
odd
could
looking
regain his
beings.
composure, he saw the beings walk right through the wooden door. Thus began one of the most bizarre cases of alien abduction in the annals of ufology.
Uh,
Next we have excerpts of Betty's regressive hypnosis. Be aware,
yeah.
some of this content may be disturbing to certain individuals.
Uh-oh.
Yes, it was. If you would, give us background so we can lead up to what I understand is going to be a pretty startling piece of audio tape that we're going to be listening to.
All right. The audio tape that you're going to be hearing excerpts from comes from one of 14 hypnotic regression sessions, and it concerns Betty Andreessen, who allegedly was abducted by UFO occupants and given, among many other things, a physical examination. What you're about to hear is a small segment of that physical examination, and I think that you will be able to relive with her the trauma and the pain and the emotion that she experienced reliving this experience under hypnosis.
And she is under hypnosis and recounting the event itself.
Reliving, not recounting. Reliving.
Okay.
She's there.
Listen.
Okay.
Why do you have to put that in my nose?
All right.
Let me know when you want to stop
I'm
this.
putting that thing in my nose and it's going up and it's breaking through something.
Okay.
I-
I want you to stop it.
I will. Okay, whatever happened to her, she definitely believed it happened. All right. So
yeah, that's
I would.
okay.
I will say, yeah. So instead of playing all that, let me just briefly summarize with this page where it says. So, anyways, basically, the story is she was taken by aliens outside to a waiting craft, which rested on the side of a backyard about 20 feet in diameter. After she was aboard the craft, it joined a mother craft where she underwent a physical examination and other stuff, some other tests.
So,
and then there was her family. When she arrived, her family was in a state of suspended animation. Blah blah blah.
yeah.
So she was able to recall only certain things at the time of her experience: the power outage, the red light through the kitchen window, and the aliens entering the house. Before this, she had little or no knowledge of UFO folklore and been a devoted Christian. She believed the abduction had a religious meaning. It would be later she began to view the abduction as alien in nature.
Oh dear.
And then 8 years later, Betty answered an ad from Dr. J. Allen Hynek, who was soliciting abduction experiences from the general public. Her letter was dismissed at the time because of its details, and it would be, January 1977 before the story would be fully investigated. Anyways, so the team assigned to her this case included a solar physicist, electronics engineer, aerospace engineer, telecommunications specialist, UFO investigator, used the service of a hypnotist and medical doctor trained in psychiatry, and she was given 12-month investigation, also given 2 lie detector tests, psychiatric review, and 14 regressive hypnosis. All right, so
well, I don't, I'm sorry that happened to her, whatever it is. I do have a theory about the alien abductions. I don't know if
yeah, tell me about that.
Okay, they're you know how in the in America you can go to medical school offshore, like if you can't get into medical school in the United States or in North America, I should say, or in Europe, you can't get into medical school. You can go to medical school at a lesser medical school, some place offshore, maybe in the islands or someplace like that. Well, this is the analog of that. These are the aliens are bad medical students, are bad students who are in medical school, and they're using us as the experimental. They can't afford cadavers and good medical equipment, so they're bad medical students from an alien.
They're
galaxy.
Bad medical students who decides to come to Earth and
right. They want to
pigs,
yeah. So they're using us as experimental animals, and that's why they're all these medical examinations are botched. It's like they
right. I mean,
right.
Like what is going on here? I mean, what?
So anyway, that's my theory.
I like that theory actually. I mean, it reminds me of. Yeah, why wouldn't
I'm completely unserious about that, and I don't want anyone.
All right. So I mean, that's pretty funny though. I mean, you joke about it.
No, I don't think there are any aliens.
Yes. Okay. So with that said, whatever happened with these examples, whether I don't know whether regressive hypnosis brings back real memories.
I don't even know if
memories.
Hypnosis. I don't even know if hypnosis is even a real thing. I mean,
really,
I'm skeptical about it. That kind of thing. As I am of what is the needles? The Chinese
acupuncture.
Acupuncture. I'm skeptical. I don't think acupuncture does anything.
You're skeptical about a lot of things.
Well, I mean, have to be, because how does sticking a needle into you do anything? Oh, well, it's an alternative medicine. I go, which means it's not medicine.
I mean,
an alternative medicine is an alternative, right?
I mean,
you can shut me up very easily by showing me some evidence of that, something that's not subjective. Like I propose an experiment where you take patients who are suffering from, I don't know, arthritis or whatever it is that
end up talking about acupuncture. Oh, because you wanted to talk about Okay.
Oh,
go on.
well, yeah, we're out of time.
We are, and frankly, I don't want to get in discussion with you about acupuncture,
Okay.
but that is maybe at a future time. But I would say there's probably a lot more people that believe in the efficacy of acupuncture than alien abductions. I don't know.
I wouldn't doubt that. I think that's possible.
So, but I mean, I think in terms of acupuncture, there are medical papers in regards to that. Now, whether
We can take a look at them. I
we
mean,
can definitely,
it would be kind of like a different direction that the
yeah,
show, because we are
that,
kind of a space show, but
that's for sure.
Mhm.
Although, yeah, I mean, we can talk about space medicine or health at some point,
Okay.
and other things of that nature. But yeah, I mean, I don't know how you would do a scientific study of UFO abductions, though. I mean,
I don't know.
that's a
Yeah.
definite different thing.
I
I presented
I
that.
feel bad. I feel bad. I think that she really suffered something, and I think there's other people who've claimed who've had similar kinds of experiences, but I don't think that they experienced a alien abduction. I think that they have. I
Well,
think, yeah,
I think I reserve judgment on
of
what
course,
people believe in. Now, your experiences are what you feel is true, is you cannot discount that. But what has actually happened,
can't dispute.
you
Yeah,
could dispute that.
the way people feel, what somebody feels, is not something that you're is open to dispute.
Nope. So,
Yeah.
with that, I have to say, look up, because you never know what you will see. So, you've been watching SG2 on Space, the only weekly
Woo!
space show, www.facebook.com/theshin show. In the future, I will also put a YouTube link, but you could watch this still on facebook.com/theshin show. Support the show on patreon.com/SG2 on Space. And,
You can do that right here.
oh wow! Look at that!
Yeah.
Look at that! Look at that! Support the show
Mhm.
there, and of course, we will be back next Wednesday, 6:30 p.m. U.S. Central Time for the live show. And of course, you can watch all previous episodes either on Facebook or YouTube. So, what is it that you say? Oh, normally I play some background music, right? Yes, there's
You're
always.
a little off of your game tonight.
I am. Forget it. Forget the background music. Whatever. It was just going to be a nice little calm observatory, but
Okay.
with the alien abduction video, there's no calming down now. Whatever.
Okay.
All right. So with that, I gotta say, what is it? Namaste, everyone. We'll be back.
Absolutely. Good night.
Good night.